A friend of IGS and certainly a friend of the commercial beef industry here in Australia is the founder of Australian Genetic Solutions AGS, Mr. Winnell, and he's going to talk to you about the implementation of EPDs.
Thanks, Luke. Just 2 secs, guys. Let me get my glasses. That one.
That one?
Thank you. How do we flip through?
Yep. So we've got. So that should.
Flip this through.
No.
Thanks, guys. So I think on the schedule says something like, does it say? Why EPDs and how to use them. When you come to these things, they're really great to have a topic like that. Kind of look forward to it. We've got Jasmine Green to speak. We've got Richard Abs to speak. You want to be awake for that. You see this, you think, oh, I'm going to have a nap. That'll be wonderful. But we'll handle it a little bit differently for you. I just need my number. I'll work it out as I go through. We'll try and handle it a little bit differently. So I think one of the problems we have is we're trying to convince people, particularly the commercial industry, we're trying to sell them on a concept and we're trying to explain stuff to them. You know, you're going to come to a conference to hear someone tell you what a birthweight EPD is or EPDs. I mean, there's got to be better things to do with your day, you know. And we're trying to sell them this stuff, and you know, anytime somebody drops off a new tractor, you don't go to the office, read the book and ring the dealership, ask what the buttons do. Just start the tractor up and push the buttons. So I think we need to be a little bit that way. So this is probably not going to be quite what it looks like. Still free to have a nap, don't get me wrong. But we'll try and handle things a little bit differently. So I'll try and bust a few little myths as we go along as well. So I had a phone call a couple of weeks ago from someone asking the question about 2 bulls, same contemporary, essentially the same phenotype, essentially the same pedigree, certainly the same side, very similar dams. So I think it was birth weight from memory. One was in the 15th percentile, one on the 95th percentile from memory. And the question is, how does it happen? And it's a really reasonable question. So to answer it, part of what we need is in part to explain what EPDs are. So, in any animal, we're going to do some math, and again, nap away. In any animal, in beef animal, we know there are roughly 3 billion base pairs of genes. And that would be really, really complicated if we needed all of them. We only need about 1%. There's only about 1% that represent variation. The rest are all 2 eyes, 2 ears, you know, tail, 4 legs. So it's only about 1% we're looking at. Of those 3 billion genes, they're packed into 30 boxes, 30 pairs of boxes, so 30 chromosomes, about 100 million genes packed into each one. So essentially, in your body and in the body of all your cattle, in every cell, there are base pairs of genes. So a DNA strand has a left and a right side. And those cells are being programmed by the DNA. They're effectively the software, the cells are hardware. So the DNA is telling the cell how to behave. Well, it's some of mine, and I think it's got it wrong. But so it's quite an important function. Now, in every cell in the body, there are roughly 3 billion base pairs, except for 2 places, in semen and in embryo, in eggs. So in semen, you've got a left-hand side, for want of a better term. In eggs, you've got the right-hand side of the ladder, and that's all you get. So when those base pairs, when that single strand is created, so we just look at semen for a bull, when that single strand is created, those 30 chromosomes have to be selected for that one semen or one sperm. Now, it can be selected from, it has to be selected from the sire, obviously, but it can be selected from the left-hand side of the side's DNA and the right-hand side. Now, I didn't believe this. If you toss a coin 30 times and go heads or tails and look at how many different outcomes you can get. It's over 1 billion. And I am such a nerd, I actually sat down and worked that out. And it turns out it's right. So this random shuffling of genes, gene shuffling and early sampling, there's in every sperm, there's a potential for over 1 billion unique combinations. And that's just the sperm. So then we get onto the dam side, and you can go again. So how does a bull, just going to go back. So how do two bulls very closely bred, very much run the same contemporary, very much down to the same phenotype, end up with so much separation? Well, it's because in every animal there is a unique shuffling of genes. And it's a good thing, because you can't make gain without it. And you wouldn't need genetic evaluation without it. But what the genetic evaluation is trying to understand is, in each of those animals, what is that random sampling of genes? So that's the purpose of EPDs or EBDs. That's what we're trying to understand. What is the unique combination in each animal? And it can make that much change. And the great thing with genomics is you can pick that up in non-parent animals. You're not waiting for big runs of progeny to give you the information. So the other thing that comes out of genomics, for example, we know that if we go back to this slide, we know that half the DNA comes from the sire and half the DNA from the dam. We know there's a random sampling occurring. So if we take that pedigree up another step, then we can speculate that 25% of that animal's, the bottom animal's DNA has come from paternal parents. And on average, that should be right. Problem is, in reality, it's not. So we know that full siblings, on average, will only inherit about 50% of the genes from the parents, or the same genes from the parents, and that's on average. So one of the things that can be done with genomics, if the grandparents' DNA, is to look at how much of that is coming from each of those lines. And then you start to adjust pedigree matrix. So when we get back to this one, and I just wanted to, because this is a common one, we often wonder this, how are these bulls different? Got different data, they're so damn similar, and it's because they're not similar. So genomics is particularly, but the whole purpose of evaluation is to help us understand this random shuffling of genes. And so we talk about why EBVs or EPDs. This is why they exist. So just briefly, and I'm just going to steal Marty's thunder, so I was smarter than him for that much. So how powerful is that for us? So if you haven't seen these graphs, this is effectively saying that on a non-parent animal, a genotype is equivalent to, or the increase in accuracy is equivalent to how many progeny records on average. So if we look at birth weight, equivalent to about 22 birth weight. If we look at stay, it's about 15. I think there's numbers a bit higher now, docility about 25. So that's the power of that genotype. Added to your evaluation and starting to understand how much or the unique combination of genes that animal has. So that's the why of EPDs and EBVs. We can say they're all similar. They all look similar on paper, but under the skin, they're just not. So the next one is looking at, I suppose, how do we get to this point? So this is really basic. So people who have a good understanding of genomics can nap right now, because you probably won't think I'm 100% on track. So I'm going to cover the basics, just keep it simple. So how do we make genetic evaluation work? This is one of the other myths. So a phenotype is equal to the genotype plus the environment. So the phenotype is any measurable trait. So we know that you get a heifer with a 350 kilo weaning weight, that's the sum of her her genotype or her genes, and the environment she was raised in. We know that to be right. So we can rewrite that equation to ask what is the genotype. That's what we're trying to understand. What's the random shuffling that's occurred? So a genotype is equal to phenotype minus environment. It's basic statistical math, it's nothing crazy. So we know what the phenotype is. We're talking about a heifer with a 360 kilo weaning weight. We've half solved the equation. All we need to know is what E is. And E is the problematic one. How do we assign a kilo value to that based on all the different environments that are out there? And the reality is we can't. But there is one thing we can do with E. If we know that all the animals we're looking at were raised in the same environment, we can start the whole E constant. So we can say E is the average of the contemporary. So if we look at a couple of different sides, we can see the variation. So if we said the average of the contemporary was 400, we can start to solve that equation. Now we need heritability, we need deviation and other things, but at its very simplest form, this is all we're trying to do. If we form good contemporaries, we start to understand the E. Now, that's not to say there won't be other bits and pieces in the equation. Are we understanding this perfectly? Probably not. But we are getting the genetic variation out. So we go back to the very simple equation. If we form good contemporaries, get an average, we know the E, we're measuring the P. So how important the contemporaries become? So one of the big issues and one of the big things we see when people ask the question about why their EPDs or EBVs look a certain way compared to the animals they're looking at. So just remember that T equals P minus E. So let's say in this group, the heifer average is 340 kilos. Heifer A is 330, heifer B 380. So what can we draw from that? Well, we can, we've still got other elements in there, but we can say heifer A is a little bit below average for weaning weight, heifer B the higher growth heifer in the group. And that's how it should be. So Jackie touched on this before. So one of the biggest issues we see with contemporary data. So let's say you had 100 heifers and you're not going to join 40 of them, you're going to kick them out. So the temptation is to say, well, I'll just weigh the ones we're keeping. So let's say you only weigh the top 60 and you take that heifer average to 370 kilos. So your E is 370 at this point. E was 340. So our slightly below growth heifer is now absolutely below average for weaning weight. Our heifer that was well above, and the high growth heifer for weaning weight comes out slightly above. So we're telling the system this. System can't know that we drafted 40 out. So one of the biggest issues we see is to try and bust some of the myths that are around this. We need to solve E to solve the equation. To solve E, we need to form contemporaries. When we're forming contemporaries, measure everything. Measuring your worst cattle makes your better cattle look good. The danger is that we start to pull everything down by limiting what we measure. So the third myth we see with EPDs and EBVs all the time. So this is an old example, I guess. A weaning weight EPD of 2 probably isn't going to go on the side or anything. But let's say one has an EPD of 2 and one of 22, huge variation. But we have to remember whether it's an EBV or an EPD, it's an average. So one of the things we get asked all the time is I've got a high growth bull with progeny that have averaged less than a low growth bull. And if we look at that in isolation, you can ask the question, but if we look at it across the population, what we get into is the average. But there is a distribution of those weights. So it is entirely possible that you can have a high growth bull representing a lower growth progeny than the next site. But remember, we're coming back to the average. So there's always going to be some distribution. Doesn't mean that what we're describing genetically is wrong. So why, we've done the why, I guess, but there's three of the common myths that I hear about this stuff. And that's okay, it's not for everybody, you don't have to get on board. But there are reasons to this. Big reason it all exists is for us to try and understand what's in that animal. And no matter how good we think we are, we don't know what's under the skin, and we know it'll be unique. So how do we use EPDs, right? In this, and so this is my take on it. Others will have a different version. So the last really big one I hear all the time is my animal doesn't represent the numbers. And I think great, because it shouldn't. And we'll get to that one in a minute. So to try and explain this and where EPDs fit in and EPDs fit in from my point of view. So let's go through how I select bulls, and others will do it differently. But when I'm picking bulls for people, how I do it. So I have three non-negotiables for me: structure, temperament, and fertility. So no matter how good a bull is, if I'm going to throw his progeny out, I've lost the effect of the genes that I've imported. So they're of no use. Doesn't matter whether it was a 3 gram bull or a 300 gram bull. If I can't retain heifers because their structure breaks down, their fertility's no good, or they're trying to kill me, then they've got to go. So for me, selecting bulls, I start with those three things. The next thing I always do is go and try and look at the cow herd. And the reason that's important to me is that 50% of our genes that I'm going to buy have come out of that herd. So I want to know that those cows are better than the cows I've got at home, for one. I want to see if the seed stock guy is practicing what he's preaching. And I want to spend a bit of time with him and know that I can trust him to back up what he says. So step 2 for me is always get a good look at the cow herd. Step 3, and this will be a bit different from maybe what others do, but I always select on type. And the reason I select on type is there's a type that fits your environment. Now that changes from place to place to place and outfit to outfit. If you have to change your environment to suit your cattle, you're doing money. Right? So I will select on a type that's going to fit that environment. So type's really important to me. So at this stage, we've gone through. We've got non-negotiables, we've seen the cow herd, starting to get catalogues in, going through pedigrees, going through all the information that's there. And then we're starting to think, well, time to go and look at a bull. So while I'm looking at a bull, I've got to try and assess docility, I've got to check structure, I'm looking for the type that suits me. I've got to get a steak sandwich in. There's a discussions to be had, there's a lot going on. Agents and bias, all of that. There's a mountain of stuff going on there. And really, it's probably down near enough. There's some raw data I pay attention to. Scrotal size, structural assessment. There's a lot to get through. And for a lot of guys, let's face it, in the beef industry, that's enough. That's really all they're going to do, and we know that. So at this stage, we've gotten through all that, and nobody's even talked about EBVs or equals. So where the hell do they fit in? Pretty simple. So if I'm a seed stock guy and I've got that, I've ticked the boxes, practicing what I preach. I've got a strong cow herd at home. I've got the structure right, the temperament right, fertility right. I've got the right type, presented them well, did a really good steak sandwich. That's important. How much more do I need to have a good payday, right? Because we know that that's pretty much a big profit driver. So that's enough to get paid. If I'm a commercial guy, though, what do I get paid on? I get paid on how the progeny perform. I'm not saying any of this stuff isn't important, it is. But they're going to get paid on how the progeny of those bulls perform. Which is why I say it's for commercial breeders. So why doesn't the bull look like the EPDs or the EPDs in the book? And at the end of the day, when you're at a bull sale and you're trying to make these decisions, you see the cattle in front of you, you see the catalogue, which one are you going to believe? It's got to be the one you see, right? But the reason they don't necessarily line up, when you're looking at that animal in front of you, about 30% on average is heritable. The rest is just environment. It's not going to translate to progeny. And if I'm a commercial guy, that's what I need to know. These are the traits that are going to drive profitability in my herd. The numbers don't look like the book because the numbers aren't trying to describe the book. Trying to describe how the progeny perform all those traits. So where does all this stuff fit in the end for me anyway? It's at that point, you know, select how you want to select, but commercially speaking, the profit drivers, a lot of the key profit drivers are going to come from those numbers. They don't have to match the cattle they're seeing. They do have to describe the progeny you're going to get. And we need to be able to do that because we know that the genes in each animal are just so randomly selected. So whilst we can see what's in front of us, we can't see what's under the hood. So to me, I suppose, trying to bust a few myths around it, but why, why EPDs or EPVs? Because you've got this random shuffling effect. How do we use them? We use them to figure out how these cattle are likely to perform, or the progeny are likely to perform, either in your herd or in your commercial herd. So that's about all I had, guys. Never thought I'd have to do a presentation again, but I must have got that. As the old saying goes, you heard me before, you not me now.
Questions for Graham? Would anybody like to tell us what the difference is between an EPD and an EBV? When you're looking at it, you don't have to give all the science behind it and all the technical stuff, but I've had this conversation with a couple of you today, so I know there's people out there. Anybody like to know what the difference is? If a bull has a let's say a yearling weight EBV of 150, what would his EPE be? 75, right? It's 1/2 of the EBV. So if you're trying to translate that, it's just 1/2.
So why, Luke?
Because we're looking at because that bull, the reason we look at EPDs is only being 1/2 of the estimated breeding value, while the expected progeny difference is 1/2 is because the calf is inheriting only 1/2 of its genes from that side. So therefore it's 1/2 that big.
So in layman's terms, an EBV is trying to describe the genetic merit of the animal, and EPD the genetic merit of the progeny. That's why I have.
Any other questions from the group? Wow, okay, all right.
Nothing